dou Ez by dou y, and this is expression for hx, and final you write the expression for hy minus gamma by h square into dou hz by dou y minus j omega epsilon by h square into dou Ez by dou x. So these four expressions are very very important in our first unit. So every topic these terms are occurring. In every topic you take a directly on that particular place, just you write the expression for ex. So where it is comes, that equation is coming from here only. So how to get like this? You solve the 4, 5, 6 and 7, 8, 9 equations. So after solving these equations, you are get a ex term, ey term, hx term, hy term. Okay, these are all the expression field for electric and expression field for magnetic. Okay, this is the combination of electric and magnetic. Okay, just you see what is the trick. Okay, first of all, you remember this equation: ex equal to minus gamma by h square into dou Ez by dou x minus j omega mu by h square into dou hz by dou y. So what is the difference between these two terms? Just you remember, wherever x is there in equation 10, just you simple y. Wherever y is there in equation 10, just you replace with x. In place of x you write y, in place of y you write x. That is the difference. So positive, negative. This is the negative. Just you remember. Okay. Remaining as it is you write. Okay. Wherever you x, you write y. This is the difference between these two equations. Next you go for this equation. This equation is came from here also. How to get? In place of mu, you simply write epsilon. Mu is the permeability, epsilon is the permittivity. That is the difference between these two. Okay. Next, here also minus gamma by h square minus gamma by h square. In place of Ez you write the hz. In place of hz you write the Ez. That is the difference between. So remaining all are same from this equation to this equation. So after we are getting hx, you write simply hy. So how to write hy from hx? Just you remember, wherever x is there you write y. Wherever y is there in hx you simply write x. So remaining all are same, but in place of plus you write minus. That is the difference between these two and these two. Simple manner. Just simply you remember trick. So how to get these equations? Okay, these are the expressions field for ex and ey and hx and hy. Okay, so after we are got this equation, I want ex value, I want ey value, I want hx value, I want hy value. Why I want these values? Just TEM mode is exist or not. Just you check these four values are exist or not in rectangular waveguide. That is the purpose of this topic. Okay, so okay, what is the definition of TEM mode or TEM equation? The definition of TEM where the electric component and magnetic component, the both component means the electric component and the magnetic component. These both components are transfers to the direction of propagation of that particular waveguide. That should be is equal to zeros. That is Ez is equal to 0 and Hz is equal to 0. I already initially explained. Just you see what is the definition of TEM mode. So both electric component and magnetic component or transfers to the direction of propagation of that particular waveguide, like circular, rectangle, whatever it may be. Okay, so that is Ez is equal to 0 and Hz is equal to 0. So these two values are substituted in this 11, 10, 11, 12, 13th equation. What we are getting? Just you observe, wherever Ez and wherever Hz is there. So in place of Ez and Hz, you simply substitute 0. So after substituting these zeros are in this equation, what we are getting? So ex is equal to, this is 0. So Ez is 0. So this term is completely 0. Here Hz is also 0. So this term is completely 0. So 0 minus 0 always should be 0. So ex equals 0. Next ey, in place of Ez and in place of Hz, simply 0. You simply substitute 0. So 0 plus 0 is equal to 0. Hx, here also 0, here also 0. 0 plus 0, 0. Minus 0 plus minus 0, totally 0. So what we are getting? The finally ex is equal to 0, ey is equal to 0, hx is equal to 0, hy is equal to 0. So what is the use of these equations and how to do and why to do up to like this? So there is no use. There is no use using the transverse electromagnetic. Only use based on transverse electric mode and transverse magnetic mode, but not use transverse electromagnetic in rectangular waveguide. So because of this explanation, I'm saying this topic only. Okay, so just you observe what we are getting final. For TEM mode, this is already I am saying said. Okay, for TEM mode, EZ equal 0, HZ equal 0. Substituting above values are 10th, 11th, 12th, 15th. What we are getting? EX equal 0, HX equal 0, EY is equal 0, HY equal 0. Hence the TEM mode. Hence the TEM mode cannot exist in a rectangular waveguide. So this term is very important. You remember. Okay, a TEM mode. For this term, I am saying up to now here. Okay, this term is very important. TEM mode, that means transverse electromagnetic mode, does not exist in rectangular waveguide. Okay, this is the topic, complete topic for impossibility of transverse electromagnetic wave in rectangular waveguide. That is TEM mode does not exist in rectangular waveguide. Okay, the proof is over. And the next topic is analysis of TE mode and TM mode. TE mode and TM mode. What is the analysis of TE mode in rectangular waveguide, and what is the analysis of TM mode in rectangular waveguide? That is also have separate topics in our first unit. Okay, this is TE mode analysis, and next TM mode analysis also there. So these two topics are very big topic. I'm saying in the next lecture. Okay, I'm saying in the next lecture, that is TE mode analysis in rectangular waveguides. Okay, I hope the students are clearly understood. If you have any doubt, just you directly call me or message me, then I immediately respond of you by because corona effect. Otherwise I'm ready to say in a blackboard, but unfortunately we are all are at home only. Okay, this is only choice for you reading the subject or you studying the subject. Okay, don't miss this opportunity. To all the students, keep it up. Thank you so much.